Okay, on the fly here, I'm going to talk about the brain here, and I'm going to try to do it in only 10 minutes or so. So first, let's talk about the structure of the brain, the actual rudimentary structure, anatomy of the brain. First, talking about the lower levels of organization. So, besides the neuron, which you've probably seen plenty of times, so the outside is the gray matter. There's also gray matter on the inside, and this area probably regulates, well, we already know that it regulates neuroconduction, neurotransmission between one cortical area and another cortical area, using the caudate nucleus and the putamen, which make up the striatum. The globus pallidus, which has an external and an internal segment. The internal segment is inhibitory to the thalamus, to the mediodorsal, ventral anterior nucleus, the ventrolateral nucleus, and probably also the ventral posterior areas that have your sensory information there. That last part I don't know about. But the external, indirectly, the external globus pallidus here, which I'm not showing the division, but it's very small and slight. The external globus pallidus inhibits the subthalamic nucleus, which I don't show here, but it's around here somewhere. And that actually promotes activity of the internal globus pallidus, which inhibits these projections that are going up to the cortex, that are already probably coming down from the cortex and going back up. So this part here is inhibiting, this part here is inhibiting something that's promoting, so these two are at odds with each other. This is the putamen here, and this is the caudate nucleus, as I mentioned earlier, that making up the striatum. There are two pathways initiated, or at least that come from these two structures. This is the coronal section of the brain. This is actually very dynamic, what these look like as we change rostral to caudal, rostrally to caudally, it changes what these look like. The caudate nucleus is very large, encompassing an area like this. If you go really far rostrally in the brain, the putamen vanishes. The caudate nucleus has connections to this part of the brain up here. It might be involved in OCD and some of the more cognitive processes related to what we think about and when we think about it, and that process of repeating the same thoughts over and over again. The putamen is more focused upon your motor activities, regulating motor, like primary and premotor cortices, sending their projections down to the thalamus, and then going back up to like the primary motor cortex to actually initiate movement. So there's a direct and an indirect pathway. The direct pathway promotes disinhibition of movements that are initiated by the cortex already, or going up to the cortex to initiate a movement. So in the disinhibiting pathway, the direct pathway, the striatum is sending inhibiting messages down to the internal globus pallidus, which is inhibiting this. So what that means is we're inhibiting an inhibitor, so we're disinhibiting that signal that goes up to the primary motor cortex. That signal goes down to the muscle and causes it to move, or it comes back through this loop again. Okay? The indirect pathway is inhibitory towards the external globus pallidus. So in doing that, it inhibits the globus pallidus, which is inhibiting this one, that's promoting that one. So if it's inhibiting this one, it's allowing this to promote the globus pallidus, which is inhibiting the movement. And it's not going up there and telling it to make that movement down there, right? So I say all this to say just basically that we have some internal structures here that might be underappreciated, because really this gray matter up here, maybe it makes up more volume than this area here, but this is centrally located, and this can actually regulate these other cortical areas. So that's always something to consider. So we have gray matter on the outside, and we have white matter on the inside here. This white matter starts out as a lot of white matter out here, and part of that could be because of the striatum, which takes in multiple fibers. Multiple white matter tracts are going here, synapsing, and then finally it makes a decision based upon kind of like a democratic kind of vote. Then it sends a signal to the external or the internal globus pallidus and helps regulate these projections that go up to the rest of the cortex. I say all this basically, like I said, say that we have gray matter, white matter. At this point, we just have pretty much the pyramidal white matter tracts going down, and some of the sensory ones coming up to the cortex here, and ones that are coming down and going back up. Some of them that are just synapsing here. This is the thalamus. This is the putamen. That's the caudate nucleus. Globus pallidus, internal and external. This is the substantia nigra, which has dopaminergic neurons in the external part, which project up to the striatum and augment the direct pathway, which promotes disinhibition of movement, as I was talking about. The internal, that is the reticulo, the reticular part, which acts a lot like the internal globus pallidus, and inhibiting movements or inhibiting processes or inhibiting projections that go up. This is the claustrum, which not a lot is known about right now. This is the insula. The gyri of insula is in this area here, which is buried inside between the temporal and the parietal, or the temporal and the frontal lobes here, if you were to go in. Your sense of hearing includes this part right here on each side. So when you're hearing something consciously, this part of the brain is working on sorting out what frequencies of sound you hear. This would be the cingulate gyrus here, which is important in recognizing conflicts between different things. Say you're looking at something, say you're looking at a word, like let's take this example here. Let's say I write this. What does that say? What about something like this? This is called the Sprint test. A little bit funny, right? Well, when you read these, this part of the brain here on the medial aspect of the brain, this is the lateral aspect, this is the medial aspect. These are two different hemispheres, but I just drew it so that the front to back, the rostral to caudal elements were the same. So this part of the brain is active when you see this here. And notice his conflict, because this is red and this is green, right? Anyway, so I said that just to tell you about this part of the brain here, which is this part of the brain here in the medial aspect. This is your ventricular system, ventricle 1, ventricle 2, third ventricle, let's see, temporal lobe is in this region here. Depending which slice we're in this case we're probably in the frontal lobe here, but if we were to go further back, this area here is the parietal lobe. So we have white matter and gray matter. The gray matter is on the surface of the brain that you can see here, and it has 6 layers. and they're all enumerated using Roman numerals. So Roman numeral I through Roman numeral VI, which would be 6. The level 4, which is IV, is the part of the brain that receives signals from the thalamus, or the sensory, like in this case, like back here would be sensory. They're receiving sensory information in your primary somatosensory cortex, in your visual, the occipital lobe from your lateral geniculate nucleus, somewhere here around the thalamus. It's sending those optic radiations to your occipital lobe. It's receiving it in level 4. Levels 5 and 6, which would be V and VI, those are sending signals back down, either the lateral geniculate nucleus, the thalamus. As I told you, the thalamus is pretty important in sending signals, receiving signals, and sending signals back up. So levels V and I and VI are sending signals downward, even whether it be down to, say, your muscles, from the primary motor cortex, and even some of them from the premotor cortex, or just other information down to like the midbrain or the medulla down there, or the cerebellum, which I don't have shown here, which is more of a regulator of smooth movement, taking your proprioception, like how much your muscles are stretching or how long your muscles are, trying to figure out what's going on, and taking in your vestibular information and trying to correct for what this part of the brain is already initiating, and trying to tell it to edit its process and change it so that you make smoother movements. So now I've pretty much just talked about kind of the some basic things about our brain. So I'm going to start with the occipital lobe. This part receives information from your eyeball on the contralateral visual side. So if this was the left eyeball, this is the right hemisphere. So if this is your left eyeball, the nasal retina, which is the part, so my left eye, my nasal retina is on this side. That information is crossing over at the optic chiasma, like 60% of the neurons are, from either side. And it's going over to the right occipital lobe eventually, after it goes to the lateral geniculate nucleus. On the right eye, your the temporal retina is sending signals straight back ipsilaterally, just straight back to the lateral geniculate nucleus, which is on the other side, which we can't see here because this is in the way here, but it's on the back side of the thalamus lobe here. It goes to that point. Then at that point, that signal is integrated, and then it sends out magnocellular and parvocellular neuron projections that go through through this part of the brain here, through the internal capsule. The internal capsule, I guess, could be any of these here. It goes to the lateral geniculate nucleus, and then goes back as optic radiations to the occipital lobe on either side. And so you have the macula back here, which would be, you can't really see much of it here because there isn't much of the occipital lobe that's on the outside. Most of it's in the medial portion, like here, for example. Your macula, your primary visual cortex is in this area right here. Also called, what else? The striate cortex is in this area here. That information goes there. It's processed, and then it goes to upper levels in the extrastriate cortex. Brodmann's areas 18 and 19. This part here is the cuneus, and this part is the lingual gyrus. So this processes superior information, like in your superior visual field up here. This part processes information in your inferior visual field. You notice how the sky takes up like almost 50% of our visual view. We don't really care as much about the sky, I guess, right? And contralaterally, it crosses over, like I told you before. Then this information can go from the occipital lobe over to what's called V4 here, which is in the extrastriate cortex, and Brahman area 18 or 19 over here. This part recognizes color using the parvocellular input. The parvocellular is tonic, which means that it does not change its degree of output. It just keeps putting it out. If it sees a stimulus, as long as the stimulus is there, it's causing an action potential. Your magnocellular output from this area going over to the occipital lobe through the optic radiation internal capsule, going into the to the gray matter, to the cerebral cortex, to layer 4, I think 4C or something like that, 4C alpha or beta. It's going there, and that is transmitting phasic information. So that only looks at whether something's changing. If it's changing in intensity, or it's all of a sudden stops, you stop seeing it, that's more important for motion, right? So that part is right here on the lateral part of your cortex. This is called the area MT in monkeys, and we still talk about it that way in humans. If you have damage to this area, you will not be able to perceive motion. So you can't cross the street because it's like a quantum phenomenon with cars. You see a car and then you start to cross over, and all of a sudden the car is right here, and you're like, what? And so you can't really perceive motion real well here. This is color. This part probably projects up to your parietal lobe, which is important for looking at spatial information and motion. Whereas this part is going to go to a lot of areas in your recognition area, in your temporal lobe, which I'm now going to talk about. Your temporal lobe, this is the fusiform gyrus. On the right temporal lobe, and it also includes the inferior temporal lobe and almost into the medial temporal lobe. This is the collateral sulcus here. That's important for recognizing faces. So if you have damage to the right side in this area or this area here, you're not going to recognize a person. You might recognize their voice, but you're not going to recognize their face when you see them. So that's one element of the temporal lobe involved in recognition. This part is probably more auditory, and this part might be more, or some of this area might be involved in recognizing other things. So this part might recognize like what a car looks like or what a plant looks like. You know, things that you have a hobby about, for example. If you're a botanist, it would be plants. If you're a car salesman, it would be the kind of car. You just recognize it when you see it, right? You know what it is. And then you probably have an area somewhere up here that's connected to that. When you see this, you connect it to something stored in one of these areas of the brain, which would be the actual word for it, right? This area would be more involved in auditory recognition, like phonetic understanding of words, like hearing the word. This area here is recognizing the word up here. This is Wernicke's region. This is the auditory cortex, where you actually perceive sound. This is the temporal pole. Let's see, what else? This area here is important for actually consolidating and, storing memories, I guess. Maybe consolidation, I guess. When you form a new memory, you're using the hippocampus, which is buried deep in this area, which would be deep in a sulcus. And if we look at a coronal section, which would be better, this coronal section, it would be in this area here. Notice that this is the temporal lobe. This area is the temporal lobe. We cut it here though, and we took out the brainstem. We're looking at this area here. That's what this is right here. So the hippocampus is back here, and also has connections to this medial temporal lobe here. This part helps you remember where things are. If you had damage somehow to the internal part, notice the adaptive value of having it in the medial section instead of the external. If someone decks you in the head, right, then they're probably going to hit this recognition part, which would probably suck too. But at least implicitly, you'll remember something. You can still form new memories in areas. You just may not be able to tell people what you're seeing or know exactly what it is in language, but at least you know implicitly what it might be. And you can store new memories in this area. The uncus, the entorhinal cortex, the perihippocampus, and the hippocampus back behind here, buried in that sulcus. By the way, I didn't tell you what a sulcus was. Sorry about that. The sulcus would be like these darker areas here that are infoldings of your cerebral cortex. A gyrus is a more prominent external folded outward part. So the hippocampus is inside of the sulcus, buried away where we can't see it. It actually doesn't have 6 layers of gray matter. It's a little bit different than the rest of your cerebral cortex. So that's the temporal lobe for you. Wernicke's region, Brodmann's area 22 is up here. Brodmann's area 21, Brodmann's area 20, Brodmann's area 17, Brodmann's area, let's see, 18 is in this area, 19's out here. There's the extrastriate cortex. Now we're going to talk about the this is 38, Brodmann's area 38, Brodmann's area 22, and then inside on the transverse temporal cortex, gyrus or whatever, on the actual top going into the sylvian fissure here, or also known as the lateral sulcus, is Brodmann area 42, then Brodmann's area 41, and then way deep in there, Brodmann area 52, and I think the insular cortex, which we can't see, which is about the same plane as this, but has gyri inside, might be 13 and 14, I can't remember, but I'll get back to that here in a little bit. So the parietal cortex encompasses this area here. Inferior parietal cortex is here. Actually, they call it the inferior parietal lobule, now that I think of it. And this is the intraparietal sulcus here, which is again infolding. Superior parietal lobule, inferior parietal lobule, occipital lobule. Okay. So this part here and this part here are also part of the parietal cortex in this area here, like I just said. This part is the primary somatosensory cortex. That's where you actually feel like any part of your body. If you feel a sensation, you're consciously aware of it right here, probably. You feel your throat and your vocal cords, like any kind of feedback you have from that swallowing and stuff like that is going to be in this region. Your face is going to be here. Your hands take up a large region here because it's important that you feel sensation, so it takes up more of your cortex. Your lips are also really important, and your torso isn't that important. Then your legs, and eventually this part here, which would be your lower leg, your feet, your genitals. Those take up a decent amount of sensory area, right? I mean, it would make sense, right? So this is your now this is the divider. The most anterior, the most rostral part of your parietal lobule is going to be in the sulcus here, the pre-central sulcus, which includes Brodmann's areas 3A and 3B, which are concerned with proprioception and with actual tactile sensation that you actually feel. And then there's Brodmann's area 1 and Brodmann's area 2 here. Then this is Brodmann's area 5, just really, it's a really narrow area, probably mostly in the sulcus. And then Brodmann's area 7 just takes up a large space here. Now, this is Brodmann's area 40 and 31, by the way. So 7 is more like here. And you have 2 of them. Okay. It's two hemispheres of the brain. So, this area here is more concerned with spatial information, knowing where objects are. Once you've recognized them here, that information probably goes up to here, and you know where things are in space, right? If you're working on a task and it's goal-oriented, you're using this part of the brain, also in conjunction with it's pulling information from this part, and they're connected at that point. But I'm just talking about actual information that you have going on at one point in time in your parietal cortex. You're detecting motion down here. That motion information is going up to here. This is more like the where. Where is something part of the brain? You're storing that information. But in order to know where something is, you need to know what it is first, and you're using your temporal lobe, right? Okay. So Brodmann's area 7, in the superior parietal lobule up here, that's what you're doing. Now, this is the inferior parietal lobule, and this area has so many functions. It's funny, but when you think about it, like I'm trying to think of all the functions. Judgment of other people and trying to put yourself in someone else's shoes when people are saying that they're evil and you're trying to think about the situation and try to understand what they would be thinking. You're using this part of the brain probably. If you're trying to remember like some phonetic characters you were just given in your short-term memory, you might be using this, or other parts of this brain. You might be using part of this brain. But there's connections that go between these areas of the brain. So I don't know. You might be using that part of the brain to know where your limbs are in space. You're probably using this part of the brain. If you're being attentive to space, things around you, your attention is focused on things in space, you're also probably using the area in the sulcus here. I'm trying to think of other examples. Basically, things with understanding something. If you're trying to understand something, even Wernicke's region is in this area right here. Like a lot of things with understanding or knowing, like for example, right now with this, I can't remember if it's the left or right side of the brain, but using this and pointing it and trying to show you something, I'm using this part of the brain. It requires really conceptual, technical, even language kind of understanding. If you're trying to understand something, you're probably using this part of the brain somehow. And it makes sense, because this is where you make your associations, and this is where you're making the relation kind of calculations right here. The relations between different things. And this might be more conceptual even with math and stuff. If you have damage to this area, you can't, or maybe even this area, you can't calculate things. You can't tell what's left and what's right, for example, if you have damage to these areas. This is profound, though, when it's on the right side of the brain. The right side of the brain has more area that's not devoted to language. Some of this is language here on the left side of the brain. The right side of the brain actually has a left and a right, ipsilateral and contralateral perception of where your limbs are in space. So if you damage on the right side of the brain in this area, then you've damaged some of your perception of your right limbs